how do we interpret the results and what kind of conditions are we looking for? Well, if you look at the capacity of any system to deliver its output, it is equal to the number of units working in the system multiplied by the average efficiency of those units. Take a bicycle factory, making 100 bikes per day with 10 workers on the factory floor, each making an average or assembling an average of 10 bicycles each. That gives you 100 output per day. If you reduce the capacity of the factory by 50% to 50 bikes per day, you can do that in one of two ways. You can either sack half the workers and keep them working at the same efficiency, or you can keep all the workers and get them to work slower and make half the number of bikes each. Now you can apply exactly the same principles to airway function and to alveolar function. So let's look at how that applies to airway function. Let's see how that applies to airway function. The capacity of the airways to do their job is best reflected by FEV1, the forced expiratory volume in the first second. The number of units is represented by the FVC, the forced vital capacity, the total amount of air that the person blows out during the test, and the efficiency is the ratio of the two, which is of all the air the person blows out, how much did they do in the first second? That reflects how quickly they're able to blow out. When the FEV1 is absolutely normal, then airway function is going to be normal. There shouldn't be an abnormality in any of the other two parameters that make that up. If FEV1 is reduced, then it is usually reduced for one of two reasons. Either because the FVC is reduced, in which case the ratio will be normal. Those disorders are what we call restrictive disorders. Or the other pattern is where the FEV1 is reduced, the ratio is reduced, and the FVC is normal. And that's what we call airflow obstruction or obstructive disorders such as asthma and COPD. Let's jump in and look at a couple of real patients. This is a person who has mild to moderate airflow obstruction due to asthma. Now, if you look at the printout from the spirometry, it's basically a lot of numbers on the page. So what do they mean? Well, the first thing is that those parameters we've been talking about, the FEV1, the FVC, and the FEV1 over FVC ratio, there are predicted values for those printed out usually in the left-hand column, and those are based on the person's height, age, weight, and sex, because they are the things which determine different size and shape of your lungs and basically allow you to predict how big somebody's lungs should be. So that's what's in the left-hand column. Then the measures that are actually obtained during the test are in the next column. And the third column is what percentage of the predicted value did the person do for each of those parameters. So jumping into this person's results and looking at the results, you can see that the FEV1 is significantly reduced at 56% of what it should be. So what's the cause of that? Well, the FVC is relatively normal at 87% predicted, in fact well up in the normal range. And the ratio is significantly reduced at 53%, the absolute ratio 53%. That should always be above 70. So this person has reduced FEV1, normal FVC, reduced ratio, that is moderately severe airflow obstruction. Definitely airflow obstruction, no sign of any restriction here. Now what the staff did in the lab when they saw that is that they gave a bronchodilator to this person and remeasured 15 minutes later. What did the results show then? Well, the FEV1 had come up from 56% of predicted to 77% predicted. That's an absolute increase of over 800 mils, nearly a litre, a huge increase, or a relative increase of 38%. Now, if you get an increase of 15% or above, that usually indicates that there's a significant asthma component to the airflow obstruction. So when you get that kind of airflow obstruction, you're thinking about asthma and COPD in particular. There are some other disorders that will give you airflow obstruction, but really it's asthma and COPD in the majority of people. And if there's a positive bronchodilator response, as there is here, then it's either pure asthma or COPD with a significant asthma component. Spirometry is the test that we use to measure the function of the airways, the breathing tubes. It is a relatively straightforward test, although some patients do find it a little uncomfortable, particularly as Damien mentioned earlier on, the bit at the end where they're trying to get you to absolutely empty the last bit of air out of your lungs. You feel that you haven't got any more to breathe out, but there is a little bit left. And that bit of being pushed at the very end can be a little uncomfortable. The staff in the respiratory lab or the staff carrying out spirometry absolutely have to get you to take a full breath in at the start and to absolutely empty your lungs out at the end. Because without doing that, the results can be a little bit unreliable. When a reliable test is done, it's hugely valuable, particularly in determining whether people have airway disorders such as asthma and COPD. Of course, there are other ways that we measure other parts of your lung function. Gas transfer to measure alveolar function. We can measure volumes to see how big your lungs are. And then we use radiology, chest x-rays and CT scans for other purposes. But spirometry is the key test to tell us how your airways are working, and a really important part of the toolkit that we use overall to work out whether you have any lung disease and what type of disease that might be.